You know, every single time you check your phone for directions, or watch a video on a screen, or even just drive your car over a bridge, you are living inside a world that was, in many ways, designed by one person, Sir Isaac Newton. And he wasn't just some scientist who had a thought about gravity. No, he was the foundational architect of our entire technological age. He's the guy who basically wrote the rulebook for reality as we know it. I mean, just listen to this famous epitaph. It perfectly captures the almost mythical status Newton achieved. It makes it sound like science was just this dark, confusing room, and Newton was the one who walked in and finally flipped on the light switch. He wasn't just seen as an inventor, he was seen as a revelation. But that really brings up a fascinating question, doesn't it? Was this really a moment of pure divine inspiration? A single flash of lightning? Or was it something more deliberate, more systematic? Was Newton a magician pulling a rabbit out of a hat? Or was he a master craftsman with a very, very specific method? To answer that, we've got to go way beyond that simple story of an apple falling from a tree. We need to actually look at how Newton worked. Because his process, his method, was just as revolutionary as any of his discoveries. Now, this might sound like a quote from some modern productivity guru, right? And, well, it is. It's the core idea behind a concept called deep work. But what is absolutely incredible is that this 21st century idea perfectly describes the secret to Newton's 17th century genius. The parallel here is it's striking. Historical accounts tell us Newton had a prodigious appetite for work and was exceptionally organized. He'd lock himself away and work for days on end, completely isolated, with zero distractions. He was minimizing what modern psychologists call attention residue, letting his focus become unbelievably intense. He was literally practicing deep work 300 years before anyone even had a name for it. And all that intense focus wasn't just for abstract thinking. It produced a real, tangible set of tools, what you could call a toolkit of modernity, that became the actual building blocks for the world that you and I live in today. All right, let's start with tool number one, optics. Newton took a simple glass prism, which back then was little more than a child's toy, held it up to a single beam of sunlight in a dark room, and then he did something nobody had ever thought to do before. He deconstructed light itself, proving that white light wasn't pure at all, but was actually a mixture of all the colors of the rainbow. And this one discovery revealed this hugely important distinction. See, Newton showed us that light is additive. You combine all the colors of light, you get white. This is the complete opposite of paint or pigment, which is subtractive. You mix all those colors together and you just get a murky black. And the screen you are watching this on right now is a direct descendant of that discovery. It uses tiny red, green, and blue lights, an additive RGB system, to trick your eyes into seeing every single color on display. Okay, next up, tool number two, calculus. Newton himself called it the method of fluxions. And it is, and I'm not exaggerating here, it's the mathematical language of the modern world. Before calculus, math was fantastic at describing things that were static, things that stood still. But calculus gave us a way to describe and even predict a world that's in constant motion and change. And let me be perfectly clear. Everything on this list, it would be completely impossible without calculus. From the engineering simulations that design our bridges and our airplanes, to the algorithms that power our computers, calculus is the engine running under the hood of our entire technological infrastructure. But Newton wasn't just a theorist. He took his systematic way of thinking and applied it to one of the most chaotic, messy, real-world problems you can imagine, running the entire nation's economy as the master of the royal mint. The English economy was in a total crisis. It was plagued by counterfeiters. So Newton steps in and applies the principles of what we now call rational mechanics to the whole problem. He treated the mint like a physics experiment. He used rigorous testing, metallurgical analysis, and kept meticulous data to create a predictable, standardized system. In doing so, he stabilized the nation's finances and basically established the gold standard. And believe me, this was not an easy job. He had to deal with some seriously messy office politics. His colleague, the famous astronomer Edmund Halley, wrote to him complaining about this one proud, insolent fellow who was causing all sorts of trouble. It's just a great reminder that even a mind that could figure out the cosmos still had to deal with difficult people to get the job done. The long-term impact of this kind of thinking was just staggering. Newton's laws of motion provided that predictable, quantifiable framework, that rational mechanics, that made modern engineering possible. The steam engines of the first industrial revolution, the transportation networks of the second, and yeah, even the robotics of our current fourth industrial revolution, they all operate on the fundamental principles of motion that he laid down. But right when you think you've got Newton all figured out, the ultimate rationalist, the story takes a really fascinating turn. Because the public Newton, the father of modern science, had a very secret and very, very different private life. Just look at the contrast here. On the one hand, you have the clean, logical precision of his public work, the famous Principia. But on the other hand, you have the reality of his private notebooks, which were absolutely filled with cryptic symbols and secret recipes from the mystical world of alchemy. Now, to our modern minds, this seems like a bizarre contradiction, right? But for Newton, it really wasn't. He saw physics, alchemy, and theology as just different paths leading to the exact same goal: understanding the complete system of the universe that God had created. In fact, get this, over half of everything Newton ever wrote was not on math or physics, but on these subjects. He spent decades trying to find the philosopher's stone, he used mathematical analysis to interpret biblical prophecies, and he secretly rejected the core Christian doctrine of the Trinity. For him, it was all part of a single, all-consuming quest for knowledge. So, how in the world do we put these two sides of Newton together? Well, we do it by realizing that his complete and, yeah, complex legacy is still basically the operating system for our daily reality. Okay, so it's true that Einstein's theory of general relativity did supersede Newton's work. But if you look closely at the math, Newtonian physics isn't wrong. It's what's called the limit case, or you can think of it as the first-term approximation of Einstein for more complex equations. For everything moving at less than the speed of light in a normal gravitational field, which is, let's be honest, our entire lived experience, Newton's laws are the ones that matter. That law of universal gravitation, the one inspired by the apple, that is the very reason we can place satellites in precise orbits around the Earth. It's the foundational physics of orbital mechanics that makes the GPS in your phone actually work and guide you to your destination. When you really boil it down, the stability of our buildings, the orbits of our satellites, the colors on our screens, and even the reliability of our economy, they all rest on these incredible foundations that Isaac Newton laid over 300 years ago. He gave us the universal laws for a predictable, mechanical, clockwork universe. It was the perfect operating system for the industrial age. Which, of course, leaves us with one final vital question. As we build a new world of artificial intelligence, quantum computing, and genetic engineering, what are the fundamental laws for the universe we're creating now?